So ANOVA is an acronym that stands for Analysis of Variance. So we've got the Analysis of Variance, ANOVA. So you would think that an ANOVA test would be about variance, wouldn't you?
No, isn't it that?
It was a way to test 3 or more means. Okay, so we're actually testing means. We're not testing variances. But in order to test means, you got to know the variance. Okay, so that's why we get the name. Okay, so so this is a more sophisticated test. In the past, we've done a independent samples T for two means, but this one you can do 3 or more. Okay, so let's talk a little bit about the requirements. Okay, number 1, you're going to have K random samples from each population. Number 2, your K samples are independent. Number 3, they're all normally distributed. And number 4, the populations have the same variance. Okay, let's talk about what do we mean by they have the same variance. Because obviously they're not going to be identical. What we mean by same variance means the largest standard deviation is less than or equal to 2 times the smallest. Okay? So so I've got a worksheet posted up on Canvas already. We're going to go over that. So we can go to assignments, and then class worksheets, and then you scroll down, you've got 13.1.2 worked out. Okay? All right. So, here's what we mean. Okay? So, basically, okay, let's talk a little bit about between sample variation. So, these are totally made up numbers. So, let's pretend that this, maybe you're comparing prices or something else between Ogden, Provo, and Salt Lake. So, let's pretend that's Ogden, that's Provo, that's Salt Lake. Completely just made up numbers, okay? All right, so you collect your data, you got a sample of 5, you got a sample of 5, you got a sample of 5. Now, the ANOVA test doesn't really care if your sample sizes are the same, but they should be pretty close. But if they're not the same sample size, that's okay. Okay, so what I did is I created some 5-number summaries here. I created some box and whisker. So this is X1, X2, X3. I should really update this. Okay, I should do that. Okay, well, now I'll do this. It's about time. I don't need that dumb thing. I didn't even put any medians in here. I should figure out what is the median on this. Oh, it's right there. Oh, 5, 8, and 11. Anyway, this is really what I'll do. X1, X2. We're going to change these. We're going to put Provo, Salt Lake, and Ogden, so that we pretend they actually represent something. And this one's going to be Logan and St. George and Orange. I'm just making this up. Whatever. These are just it's fake data, but it makes more sense. Okay, so sorry. Let's do this one more time. Ogden, Salt Lake. No, this is Provo. Sorry. Provo, Salt Lake, Ogden. Logan, St. George, and Orange. Okay, those are just names I could think of. Okay, all right, so as we look at these, so let's compare Provo, Salt Lake, and Ogden here. And as we look at these box and whiskers, notice there's not many whiskers there because it's really tight distribution. Just visually, if you were to look at these 3 boxes and whisker, it would probably be pretty obvious that the mean in Provo is different from the mean in Salt Lake, which is different from the mean in Ogden. I mean, is that kind of obvious, right? Okay. Now, these don't overlap at all. This is probably going to be significantly different than this, which is significantly different from that. Okay? I mean, visually that makes a lot of sense. The problem arises then, what if you get into Logan, St. George, and Orem, okay? These overlap quite a bit. So it's hard to tell if Logan's different from St. George. It's hard to tell St. George is different from Orem. You might be able to say, well, I think Logan's different from Orem, but I'm not sure, you know, because there's a lot of overlap there, right? And so in order to properly compare these, we need to look at the variance. And that's why we call this the analysis of variance. So as we look at these, okay, so I found out the mean. The means are 5, 8, and 11, okay? As we look at the standard deviation, so I got 1, 1, and 1.22. So as I look at this, I want to say, are these the same, okay? So the smallest here is 1, say Provo. 1, if I double that, that's 2. 1.22 is less than 2. So yes, it is, we're going to call that the same variance. They're not significantly different, okay? All right, so it meets this criteria right here. We're going to assume these are normally distributed even though they're small, okay? I'm going to skip that. Okay, so I've got my 5-number summary here. I've created this, okay? All right, so now that we've verified that yes, it has the same variance, I need to define some more terms for it, okay? As we start doing this test. Okay, so the first one I want to describe is the SSE, which stands for the sum of squares due to error. And then I want to describe the SST, which is the sum of squares due to treatment. Now in our case, the treatment is you live in a different city. Okay? But you know, you could apply this to placebos and drug groups or whatever. Then we have the MSE, which is the mean square due to error. And then we have the MST, which is the mean square due to treatment. And then finally, we have the F statistic. I'm going to give this one away to you. This is going to be an F. Okay, why is it an F? We're measuring variances, right? We measure two variances. Normally, a variance would be chi-squared, but we're taking two chi-squareds or more, and so then it becomes F. Okay? So your F statistic is going to be your MST over your MSE, okay? Now, your degrees of freedom, this is where I want to double check. I believe this is correct, but I'm not 100%. I believe, or maybe I'll write it this way. With n minus k and k minus 1 degrees of freedom. I need to double check that. I might have that backwards. If somebody wants to look while we're doing this. That's what my notes say. Well, my notes were wrong before, and I think it's right now, but I'm not 100% sure. Okay? But I believe that's correct. Okay? So, all right. So I didn't give you the equations for these, so I'm going to do that now. So your sum of squares due to error equals n1 minus 1 times s1 squared plus n2 minus 1 times s2 squared plus et cetera, for however many samples that you have. Okay? Your SST is going to be n1 times x1 bar minus x bar squared plus n2 times x2 bar minus x bar squared plus et cetera, however many samples you have. Okay? Your mean square due to error is simply the SSE divided by n minus k, and your MST is your SST divided by k minus 1.
Wait, is that MSF or MSE?
This is MSE,
Okay.
and that's MST. Mean square root of treatment. Okay? All right. So I know you guys probably like some steps. Okay? So let's talk about steps. Okay? So the first thing you're going to want to do is you're going to compute the mean for the combined data. We're going to call this X bar. Okay? So we're going to do it for everything. Step number 2 is you're going to find your sample means. X1 bar, X2 bar, X3 bar, etc. However many samples you have. Step number 3, you're going to find the standard deviation slash the variances for S1, S2, S3, etc. Okay, however many you have. Step 4, you're going to compute your SSE and your SST. Step 5, you're going to compute your F, which equals the MST divided by the MSE. Okay? Now, once again, I just want to caution you, I think that's correct, but I'm not 100% certain. I need to double check that. Okay, but what I'd like to do is I'd like to go through an example here. We're going to take basically this data here, Provo, Salt Lake, and Ogden. We're going to pretend this represents real data, which it doesn't, but we're going to pretend it does. Okay? All right, so here's our data. All right, so what we're going to do is we're going to find our combined X bar. So your combined X bar is going to simply be the mean of all of your data. Okay, we've got 5 in each thing here. Okay? All right. Then I need to find, so one of the things you may want to do here is you may want to find the means and the standard deviations of all these. Okay, so that's simply the mean of this. Copy that over. And the standard deviation of this. And we'll copy that over. Okay? So the means are 5, 8, and 11. I mentioned that on the other page, so that they are again. Your variance, so I found the standard deviation. Let's just look at the standard deviation really quickly, just to remember. So if I double the smallest one, that's 2. 1 point, the largest one is less than 2. So we're good. Okay? All right. So really what I need is the variance. So if I take 1 squared, I get 1. 1.22 squared, I get 1.5. Okay? So that's what I get here, step 2. Step 3, excuse me. Okay, now I need to find the SSE. Okay? So one of the things that you may want to do here, so let's look at my N1, well, let's look at my N, my N1, my N2, my N3. Okay? What is my N? N is going to be all of your samples. So that adds up to 15. You see that? So I got 15. N1 is 5, N2 is 5, N3 is 5, and then I need to figure out how many samples do I have. I've got K samples. How many samples are there? How many means am I comparing? Three means. Okay? So I'm probably going to want to figure out my K minus 1, and I'm going to figure out my N minus K. So my K minus 1 is going to be 2, and my N minus K, 15 minus 3 is 12. Okay? All right. So, okay, Okay, let's go to the SSE. It's going to be N1. What's N1 again? 5 minus 1 is 4. 4 times my variance. Okay? So I'm going to take 4 times my variance. 4 times 1 is 4. 4 times 1 is 4. 4 times 1.5 is 6. Right? Okay. So this line here represents my SSE. Okay? Maybe I'll highlight that a little bit. That's my SSE. Okay? Now to find my MSE, I'm going to take the sum of this previous line and I'm going to divide it by my n minus k, which happens to be 12. Okay? So that gives me a value of 1.666666. Okay? All right, now I need to figure out my SST. Okay, my SST is this line here. So SST says N1. N1 is 5 times x1 bar. x1 bar is 5 minus x bar, which is 8. So 5 minus 8 is -3. -3 squared is 9 times 5 is 45. That's how I got that 45. Okay? Then I'm going to figure out x2 bar. X2 bar is 8. Minus 8 is 0. 0 times anything is 0. And x3 bar is 11. Minus 8 is 3. 3 squared is 9. 9 times 5 is 45. Okay? Does that make sense? Okay, so there's my SST. All right, now we're going to divide. So we're going to take the sum of this line here, and I'm divide it by k minus 1, which happens to be 2. So 45 and 45 is 90, divided by 2 works out to be 45. Okay? All right, now I'm going to take my MST, which I just found. I'm going to divide it by my MSE, which is right there, and that's going to give me a value of 38.57. Okay? All right. Now, here's where I'm not 100% sure my notes are correct, and so you guys, this is the one step I'm not clear on, but I believe it's right. So I'm going to do the f dot dist, okay? So basically what we're saying here, oh, by the way, I probably should have said, what's my null and my alternative hypothesis? I went right by it, because I was so excited about doing the calculation. Okay, what is my null and my alternative hypothesis?
We're going to do means or variances, yeah.
We're testing the means.
Oh, means so.
And ANOVA is testing the means.
Mu equals
Okay, so you could say mu1 equals mu2 equals mu3. You might have a bunch of mu's here. So I'm okay, this is another exception, all means are equal. Okay? So this is the other exception to the rule. Yes, you can go ahead and say that. And your alternative is what? At least one mean is different. Okay? At least one of them is different. Maybe they're all three different, I don't know, but at least one of them is going to be different. Okay? All right, so the idea here is if all of the means were the same, what would you expect your F value to be large or small? You would expect it to be small, right? If it was large, you would expect that the means would probably be different. So in reality, is this a one or a two-tailed test? One tailed test. It would be greater than. Okay, we're going to reject if our sum is big. Okay? All right, so as we do this, now I use a different command there in yellow, which I'll show it to you really quick. You can use fdist without any periods. Okay? or you can use f dot dis dot right tail. Okay? I'm going to do the 38 degrees of freedom 1, I believe is n minus k. This is the one thing I want you guys to double check. And the k minus 1, because I might have those backwards. In fact, we're going to do them backwards and we're going to see what the difference is. In fact, I'm going to do them backwards right now. Did you find it?
Yeah.
Am I backwards?
It says K minus 1.
So just k minus 1 first. So k minus 1 and n minus k. Okay, so this is backwards. Okay, so k minus 1 and minus k. Okay, what page is that on?
Oh, wait.
Here, I'm going to show you because there's two different answers there. One of those is correct, but here's the thing, here's the point. Okay, let's make sure you have them right. And I'm sorry I didn't have better notes here. I always get those mixed up. Regardless of your answer, these are both going to tell you the same thing, aren't they? Okay? Now, one of those is correct, one of those is wrong. Okay? We'll check your homework. We'll make sure we're doing this one. But in either case, what's going to be your conclusion? If we're using an alpha of 0.05.
Do or reject,
We're going to reject the null. And therefore, the conclusion is, what? At least one mean is different. Okay? Now, tomorrow's lesson is going to be figuring out which mean is different. Okay? So anyway, check your degrees of freedom. I'm not sure if I have that right. I'll check it too. I'll try to send out a mass email to let us know. I've got them both ways on my sheet. Okay. So quiz tomorrow. Oh, by the way, one last thing. I tried to schedule the test. I've run out of tests at the testing center. So here's what I think we're going to do. Tell me if you disagree with this. We'll probably just do a paper test for the next test,
Okay.
which will be, they'll only let me do it for 2 days. So, okay, so today we're covering 13.1. Tomorrow we'll cover 13.2. Then we're going to have a week off for Thanksgiving. Then we're going to come back after you've forgotten everything. So we're going to do 14.1 on Monday, 14.2 on Tuesday. We're going to open the test for Wednesday and Thursday of that week. The following week, okay, since I can't test you on the computer part of this, the following week, the final is going to be a little bit more heavy on the newer stuff because I haven't been able to test you on that. It'll still be comprehensive. That's scheduled for Tuesday to Thursday. That's the latest they would let me schedule it during that next week. That'll be a computer exam in the testing center as long as you want. It's going to be comprehensive. And then we'll do the in-class written part of the final during the scheduled final time. So is everybody cool with that? Or the other thing is we could do a written test in class, and then I could give you a computer test on just this section, so then it wouldn't be a surprise on the final.
Let's talk about it tomorrow.
Okay, we can talk about it more tomorrow.
Meditate on it.
Yeah.
I'll pray about it.
Okay. All right. See you all tomorrow.